cosmic cloud of gas and dust that transforms into a star when it becomes large enough for nuclear fusion to begin in its center due to pressure of its own gravity. Pressure is created by the fusion of hydrogen into helium, which pushes outward and counteracts gravity's inward pressure.
A main sequence star is a newborn star that undergoes hydrogen fusion in its core and has attained a stable balance of forces. A red giant evolving from the main sequence star is a luminous giant star of low or intermediate mass.
In its late form of stellar evolution, it holds other possible outcomes. Firstly, two main sequence stars would have to be revolving around each other to get into the binary system that contains the red giant and white dwarf phase. To achieve the red giant phase, the core contrasts and the outer layers expand. The outer layers expand due to hydrogen fusion. By the time a star reaches red giant and white dwarf, we would have to have one massive star die. When a star dies, it can become a neutron star. As the star is dying, the center region of the star is crushing together every proton and electron into a neutron. This very dense object is around 20 kilometers across. By this time, the neutron star can become a pulsar or magnetar.
A pulsar is a rotating neutron star that rotates and emits lots of pulses of radiation at regular periods of time. This can range from milliseconds to seconds. Pulsars' magnetic fields funnel the light going off from its electromagnetic radiation towards the poles of the neutron star. Further on, Earth may only view the pulsar's light when directed to our planet.
As we know, a star becomes a pulsar when a massive star collapses and runs out of fuel. In this event, a supernova occurs from its huge explosion, due to the lack of opposing forces of nuclear fusion to help balance it. Gravity then begins to pull the massive star into itself and implodes, leaving behind a rotating neutron star that resembles a lighthouse, spinning and radiating lots of light in opposite directions.